Okay, we are really starting to get to some fun stuff as we get to lessons 15, 16, and beyond. We've learned how to create shapes, we've learned how to create sprites, we've learned how to make backgrounds, we've started to figure out how to make things move. But now this is kind of the first step in giving us a little control over how things move and making it possibly interactive as we kind of get into 15, 16, 17. So if you made it this far, it is going to really pick up in terms of, I think, making it more fun going forward. However, just somebody really liked having these predictions. So when we click run, let's just kind of see what happens. We've got some false, some true. We got two gray blocks, which again, if you don't set an animation to a sprite, it's just going to be a gray box. Sprite 1, Sprite 2, and it says predict what each command will print. This is down here in the console log. So when we console log Sprite 1's Y is equal to Sprite 2's Y. That is true. Well, if we look at Sprite 1, it's got a Y of 200. Sprite 2 has a Y of 200, so we plug that in. 200 equals 200. True. All right, next, Sprite 1's X is greater than Sprite 2's X. 100, 300. Is 100 greater than 300? No, that's false. And then the third, Sprite 1's X is less than Sprite 2's Y. All right, 100 less than 200. Yes, that's true. All that to be said, this is leading into something much more important, something that can be evaluated either true or false. We've got some different comparison operators. So this is just kind of walking through and making sure that we understand how human language can be translated into our JavaScript code. So on the left, we have our human language statement. On the right, we have the corresponding JavaScript code. I'll just leave that there for a second. If you need to pause and look at it, feel free. In about 5 seconds, I will click submit. Okay. All right, level 3. I'll start over here so we're on the same page. All right, there was a video under help with tips. So a little vocabulary of Boolean, that is something that can be evaluated to true or false. So this one says we need to find out if the race car has crossed the finish line. Add blocks to the text command to print the Boolean to the screen. All right, so I'm going to ignore that a little bit. So right here, the race car has crossed the finish line, and then right now it says text. We want this to change based on whether or not it has crossed the finish line. So the way we're going to do that is with something called, we're just going to evaluate it right now. So we need to compare the race car's X position with the finish line's X position. So if it's moving right to left, then whenever the race car's X is less than the finish line. So I'm going to do race car dot X less than finish line dot X. That's what's being evaluated. So if I run it now, it's false. But once it crosses, it changes to true. Okay, so that's just a straight up built-in Boolean, something that can be evaluated as true or false. Also a data type that we use in coding. So we talked about strings, which is just text. We talked about numbers. A state of true or false is also a data type, and that's what's being stored there. Okay, level 4. I guess I'm going to go blocks. This is just a view only. So this is updating it. So if the race car's X is less than, we just saw that would mean at 1. We have some text that will appear only if that is true. This is, so I like to mention kind of the 4 foundational pieces of coding, no matter your programming language. We've already covered variables. Variables would be 1. Conditionals would be the next. Okay, so this is referred to as an if statement. We'll eventually learn how to build these out with if, else, ifs, all sorts of cool stuff. So this is a form of what's called selection. There is a choice, all right? There's a situation that can involve or can be evaluated to true or false. If it evaluates to true, then the code under it executes. If it's false, then it doesn't run. So the selection for our program here is either run it or don't, and it's based on this condition. All right, level 5. I'll go back to version history here. Okay, yeah, so this one, we have an apple that's getting bigger and bigger and bigger. And this one is a very commonly erred upon task. You don't have to create a new sprite. I will start out with that. So what it wants us to do is we want to change. So if the fruit scale is greater than 2, change it to a pear. So our fruit is the name of the sprite. Remember, the sprite is the placeholder. We are just setting the image of an apple to it. We have an apple, we have a pear. So we're going to say, we now have a new menu called control. Now this is our conditional. We're going to say if fruit.scale is greater than 2, then we want to set the animation of the fruit sprite to become the pear. So you don't have to create another sprite. I've seen students get really involved and create a second sprite and try to hide one. Just change the animation. So we're going to run it. And as that grows, and down here you can see the watcher, as that eclipses 2, we'll see it switch to a pear. Okay. Okay, we got some practice problems. All right, this one, they have gotten wise. This one used to be very confusing. I think the directions now help, especially right here. I did not put that, so if my students are wondering, that is from code.org. They used to not have these directions, and it was a little bit vague as to whether or not you had to change the sprite properties or change the statements. So the simplest Boolean expressions are questions that computer can answer true or false. So modify only the values of the sprite properties in the first 11 lines of code. So we're only changing these values. All right, but we want to do that so that each of the Boolean expressions evaluates to true. So I need to see, so it's comparison 1, so right now they're all false. I need sprite 2's x to equal sprite 2's y. So sprite 2's x and y, let's make it 200, 200. We'll start there, I reset. Now that's true. Okay, let me come down to the next one. Comparison 2, sprite 2's rotation is less than 40. All right, right now it's 60, so let me make that 39, and that will be less than 40. That's true. Okay, this is comparison 3. Sprite 1's scale is the same as sprite 2's scale. That is not true at the moment, so let me just scale this one up to be 1.5. Now that one is true. Okay, comparison 4. Sprite 1's x is greater than 150. Okay, and I'm checking. There's nothing else with sprite 1's x, so that's good. So sprite 1's x, let me make that one 300. Okay, and now it's true. And then comparison 5, sprite 2's y is less than 200. Okay, so I'm going to do 199, 199, because they had to be the same. Reset, run. Okay, now everything is true. Okay. Obviously, those are not the only ways, the only answers, but I was just going one by one. With that last one, okay, you have to make sure if you change your sprite 2's y, you also have to change the x, because condition 1 was making sure x and y are also equal. Alrighty, our next practice problem is the dropped soup. This one I think I've already finished. I will just leave the code up and explain. So again, we have animations. This is really driving home the point of you don't need multiple sprites sometimes. If you need a picture to change and give the illusion of it changing, you just need to set the animation to something different. So we create a sprite called soup at 200, 200. We set the animation to stew, which is the bowl with stew in it. And then we have another one just called bowl that's empty. All right, we have a light green background, and we have our rotation set that every frame is going to rotate 3 degrees clockwise. Our directions were to add a conditional that detects whether it's upside down. So it's only going to happen the first time around. 180 to me was a little bit too far. I feel like soup falls out before it's completely upside down. It starts sliding a little bit before, so I used 160. You could probably even do 150. But I said if the soup's rotation is greater than 160, then I set the animation to be the empty bowl, giving the illusion that the soup must have fallen out. Okay. All right, practice 6C, the alien celebration. Again, with this one, we have 3 different sprites. We've got our background, we've got our spaceship, we've got our alien. Each one has its set. What this one does is the spaceship begins to launch inside the draw loop, so that counter pattern with the Y decreasing means it's going up. And we have a conditional that detects when the spaceship is in the sky. I said when the Y is less than 50. So once it reaches a certain point, all right, it's close to the top, we change the animation to the alien dance. And if you notice, this one is kind of cool. It's got 2 different frames that exchange back and forth, so adding even more movement, so you can create multiple frames for one image, which is really cool. So once it reaches that point where it's high enough in the sky, we feel like it's successfully launched. We'll change the animation of alien from that still, facing forward to turning around and dancing. Alrighty. All right, and our assessment, it says use an if statement to make the dinosaur turn into a pterodactyl. This one's always bothered me. A pterodactyl is a dinosaur, but the dinosaur is the sprite, I suppose. So really it should say make the Tyrannosaurus Rex turn into a pterodactyl. But so what we're doing, we have our background sprite called backdrop. It is set to sci-fi. We have a Tyrannosaurus and a pterodactyl. Dinosaur initially is set to be a Tyrannosaurus. It's scaled down. All right, we have this Y counter pattern that makes the dinosaur sprite move up. And then we have a conditional that says if the dinosaur's Y is less than 200, remember Y's, as we go up, it decreases. So we want it to reach a certain point in height and then change. We just change the animation, and then that will draw everything. All right, and we see our dinosaur right at 200. It changes from a Tyrannosaurus Rex to a pterodactyl. Okay, this one is loaded with challenges. I am not going to make my class do all of these. This first one, the new block, visible. This is a classic. It's been around ever since I've been teaching this course. It, again, is one that students get confused because we just had the apple and pear example, and we just changed animations. However, with this one, we actually want one animation to disappear and one to appear. So this one, you do not switch the animation. So when I run this one, and I think I may already have it set. If not, forgive me for playing it through. This one takes forever. Probably should increase the scale to make it go faster. Anticipation building. All right. Is it done? Yes. Okay, so notice it changes to pop, but pop doesn't keep growing. It just kind of stays. For that reason, we need 2 different sprites, okay? So we have a sprite called balloon. It's set to a balloon. Its scale is 0.1. We also have one called pop, and its animation is set to pop. So we have 2 different images and 2 different sprites. Okay, notice pop is not scaled. We also set the visibility of pop to false. So new tool, you can hide sprites at different times. So right now, it is not visible. All right, but we have inside our loop, every frame, the scale is going to increase by 1/1000th. Eventually, it gets to a certain point. So once our balloon scale is greater than 0.65, we then flip-flop it and make the balloon sprite's visibility false and pop's visibility true. And when we do that, it looks like the balloon has popped and that image appears. Okay, when in reality, the image was there all along, the sprite was there all along, it just becomes visible and the balloon becomes invisible. Alrighty, so that is how that one works. Okay, restarting sprites. This one looks like I did it already, so this one is kind of getting to what we call a looping pattern. So what you can do is to give the illusion of things looping around is you can set conditionals. In this case, we have our ghosts and our monster that are moving from right to left. But we say, hey, once that ghost goes off screen to the left, let's reset it to the right. So that is checking if the ghost's X position is less than -50, meaning it's all the way off the screen on the left. We reset it to 450, which is off the screen to the right, and it gives that scrolling appearance. Same thing with a monster. We use -50 and 450. And because it's inside the loop and we constantly have that counter pattern going, it just resets it, moves it, and it keeps following that counter pattern of decreasing. All right. So just from years and years of this fish scene that we're probably going to see again later as well, I'm not requiring my students to do the never-ending fish scene. It just gets old. So A and B are enough if you're in my class, but if anybody out there needs help with C, D, or E, or even creating a sci-fi scene, my students, if you are done early, I would encourage you to maybe do the sci-fi scene just for fun. If you need help with that, let me know. Otherwise, this will conclude the tutorial for lesson 15.